Okay, so the title of today's presentation is Factoring Trinomials Using Normal Factoring. Okay, what was a trinomial? Just by way of reminder, trinomial. There's a hint.
3 terms.
3 terms, right? So just some examples here, right? So 3x squared plus 5x minus 10 would be an example of a trinomial because I have 1, 2, 3 terms being added or subtracted together. Okay, and we're going to look at how to factor these, and really the rest of this chapter is dedicated to different methods for factoring trinomials. And last section we looked at factoring using the method called GCF, and there were a few trinomials there that we did factor, but really that isn't the common method for factoring trinomials. Okay, I'm going to show you what I hope is a very simple method for factoring trinomials. And to set up an intuitive understanding of what exactly we're doing, I'm going to start with a problem that hopefully you're familiar with. Okay, so if I had a rectangle, which you have in front of you on your notes, so the angles are right angles, and let's say that the dimensions of that rectangle were x plus 3 for the length, and x plus 7 for the width. With me? If I asked you to find an expression for the area of that rectangle, what would you do?
Length times the width.
Yeah, what you normally do for any area of a rectangle problem. You go the length times the width. And it doesn't matter that we have algebraic expressions for the length and width. We do the exact same thing. Okay? So let's see what that looks like. Area equals length times width, just like we normally do. And here the length is x plus 3, the width is x plus 7, so we're just going to multiply those together. Okay? So x plus 3 times x plus 7. Does the writing look better? Yeah, it's way better, eh? Yeah, I like this app a lot better. And what do we do now? How do I multiply these two together?
Distributive property.
Yeah, the distributive property, or FOIL, was a method you were taught a couple days ago. So I go x times x first, so that's just x squared. Next I do x times 7, you should be pretty familiar by now. That's 7x. And then 3 times x is 3x. And then 3 times 7 is 21. Okay? And then I'm going to add these two middle terms together, because they're common, or they're like terms. So that gives me x squared plus, make that better, x squared plus 10x plus 21. And just like when I was introducing factoring in 5.2, or common factoring, where I asked you, how do I go backwards? How do I undo the multiplication that I just did? I'm going to ask you the same question in this case. If I just showed you this, if that's all I showed you, and I asked you to factor that trinomial into the product of 2 binomials, does that sentence make sense? Factor the trinomial into the product of 2 binomials. What does product mean?
The answer. Multiplication.
Yeah, multiplication, right? It should tell you that you're multiplying something. So the product of 2 binomials. And a binomial is
2 terms.
2 terms, right? So just to give you a better understanding of what I mean, this here is a product of 2 binomials. It is the factored form of this end trinomial. And we know how to go this direction. We just multiply, right? But to go backwards, that would be called factoring. Can you see any way for how we can go from our trinomial to the product of 2 binomials, from the multiplied form to the factored form? Do you see any relationship between, for instance, the 7 and the 3 and some of the numbers down here? Any relationships you see? Just shout them out. All at once. Nothing? Really? What do 3 and 7 have to do with 21? And what do they have to do with 10?
Oh, 3 times 7 equals 20.
Yeah, right? 3 times 7 is 21. What about the 10? Does that have any relationship with the 3 and 7? 3 plus 7. Interesting. You get the idea? So it seems like this middle number is the sum of these two values here. And the end number is the product, or what you get when you multiply those two numbers there. Okay? So I hope that gives you some kind of intuitive understanding for what we're trying to do today. We're trying to take trinomials like this and factor it into a product of two binomials like this. Okay, and that relationship that you saw between the 3 and the 7 and the 10 and the 21, that's going to come in handy really soon here.